The procedure starts at the FFB reception area, where 80 and 100-ton capacity weigh bridges record the incoming fresh fruit bunches. The fruits are subsequently unloaded onto a big loading ramp, measuring 2,500 square meters and equipped with 22 hydraulic unloading gates. The bunches are then transferred to the processing line using a hydraulically operated conveyor system. Before sterilization, the steam splitter prepares the fresh fruit bunches by creating openings in the bunch structure. These controlled perforations allow steam to penetrate deeply and uniformly into the FFB during sterilization. This improves heat transfer, enhances fruit detachment, and ensures consistent processing across all bunches. After splitting, the bunches enter the vertical sterilizer, where they undergo uniform steam treatment. The sterilizer is equipped with automated feeding and discharge doors operated through a PLC system, ensuring safe, consistent, and efficient sterilization. After sterilization, the bunches are transferred to a two-stage thresher. This system separates loose fruits from the bunches. The fruitlets are then moved through a conveyor directly to the digester for the next stage of processing. Inside the pressing section, a screw press extracts crude palm oil while producing a mixture of nuts and fiber. The crude oil flows to the clarification section, while the nuts and fiber are separated in a winnowing column. Fiber is sent to the boiler as fuel, and the nuts are forwarded to the kernel crushing line. The kernels undergo double pressing to extract palm kernel oil. Sterilizer condensate is processed in the ACSS tank. Some portion of the oil is screened and sent for clarification. The remaining material is called palm kernel cake, which consists of around 2% oil and 98% solid meal, commonly used as cattle feed. Palm oil gets separated from water mixture. The purified oil is dried to remove moisture before being stored in dedicated storage tanks. Sludge from the clarifiers goes to decanters, where oil, solids, and effluent are separated. Calendrias, vapor separators, circulation pumps, and vapor ducts that work across 5 sequential evaporation stages. This concentrates effluent to 60% solids. The concentrate is further processed in 2 ATFE units, reaching 80% solids. It then goes through a blender, followed by paddle dryers that bring moisture down to 7%, and paddle coolers reduce it below 1%. The final dry product is stored in a powder silo and packed in the bagging station. A cooling tower supports the MEE operation. Empty fruit bunches are processed in the EFB station using presses and vibro screens. Recovered oil is sent to the clarification process, while shredded EFB fiber is used as boiler fuel. The plant's power system includes a 1,250 kilovolt ampere transformer, an isolation transformer from the electricity board, a high-speed turbine running at 15,900 RPM, and a 4.2 megawatt alternator with a PCC capacity of 5,000 amps. Two 3,250 kilovolt ampere distribution transformers and an 11 kilovolt high-tension switchgear support the mill's electrical load. All operations are monitored and controlled from a centralized DCS-based control room with auto-synchronizing capability. Steam for the mill is generated using 15 TPH and 35 TPH boilers. The facility operates as a captive cogeneration plant designed for mill capacities ranging from 30 to 120 TPH, along with a 720 KLD MEE plant. Fly ash emissions are controlled using an electrostatic precipitator, and the cleaned flue gases exit through a chimney. The plant includes a condensate polishing unit for treating MEE condensate to reduce COD levels. RO plant followed by MB system brings down the TDS level to 0 before feeding into the boiler. Storage tanks. Multiple storage tanks dedicated to oil. 2 1,000 kiloliters, 2 500 kiloliters, 2 250 kiloliters. Tanks in total.